If you are this is for ceramic processing and mix oxide route or solid state sintering route. You bring oxide together, you mix them, melt them using disposable polyethylene jar mills and horizontal ball milling or a treater, whatever milling procedure you use. The bottle, the simplest thing, your digital balance is usually measuring up to 4 decimal points. That is why it is important. Because when you are working on technical ceramics, then each and individual cation is important. If you are making traditional ceramics, then that much accuracy is not important. Because a few hundred or a few thousand atoms is making no difference. But if you are working at atomic scale, nano fabrication and different things at very precision, then you need to weigh the oxides precisely and the balance should be accurate, right? The bottom of the disposable cylinder looks like this. For example, like this. 1/3 or slightly less is filled with cylindrical or circular, spherical, different shapes of milling media is coming. Milling media is a hard material which, when moved around, floated inside the bottle, there is no scratching or no material is being removed from them. So it must be very hard. Then you fill this portion, for example, with the raw materials, and then you pour liquid, for example, up to this much. Tightly put the lid tightly upon it so that no liquid can come out of it. Shake it a little bit and make it sure that the lid is not loose, and secondly, the inside material is fluid. If it is not fluid, then your milling is not happening. It must be fluid. Then what you do, you put it on a horizontal mill. This is the bottom, right? And it rolls it, and the particles of the material comes in between the cylinders or spheres of the milling media, and they are continuously moved for 2 hours, 24 hours, 3 days. How much do you want mixing and how much do you want milling? How much particle size is your desired particle size, and how much mixing do you need, right? Sometimes you don't need intimate mixing. Sometimes you need a lot of mixing. For example, for traditional ceramics, you need the various phases to retain their originality. For example, if quartz is there and you don't want quartz to be homogeneously distributed, then you don't need that much milling, right? But for electrical application, electronic application, you need very homogeneous material. For that you do longer milling of the material. Once you have done that, what you do, you take a clean glass beaker, put a sieve, ordinary sieve people use usually like this. Pour the slurry onto it, right? The slurry you made here after milling, pour it in it. It was filled up to here, right? Remove the sieve and the balls. Wash them for if you want to use it again. This was the beaker. It is filled up to here. You take it to a drying furnace. Keep it there for 12 hours, 24 hours in 90 degree. For example, why 90 degree? Because the boiling point of these acetone or propanol type things is nearly that. But the temperature should not be very high so that violent boiling doesn't occur. If violent boiling occur, then this material can come out and you are losing the stoichiometry. Why you are losing stoichiometry? Because the denser material will be at the bottom and the rarer materials, the less dense material will be on the top, and if boiling occurs, you will lose the particles of one material and not the other, right? So violent, and secondly, you are making the furnace dirty if it is volatile, right? It is boiling violently. Whenever we put such beakers inside the furnace, and to avoid loss of material or spread it around, we usually put tightly an aluminum foil on the top of it and make small holes with the tip of the tweezer or the tip of a ballpoint so that the vapors can come out. Tomorrow, after 12 hours or 24 hours, you look at it, it seems dry. Then what people do, people take a pen, fit it with a sieve. This is the sieve. The sieves are available in different sizes. So you take the desired size of the sieve like this, and you put the material here, pour the powder here, and using brush they are gathered at the bottom of the sieve. After sieving, you can store the powder. They are called as milled powders. As milled or mixed milled powders. Once you have got that, the next step is calcination. Calcination is the step to develop the desired phase, right? If you had, for example, alumina, silica and magnesia, during the calcination these powder react. That reaction make Mg2Al4 Si5O18, but in the powder form.